Cool. So, I want to do a couple topics, right? So the main thing is, and as I say, I try to not make the class too long, right? So, let's see. Cool. So, as I was saying, we're gonna do a couple topics, but before we do that, let me just show you all um CSEC math tutor, right? If you need to get any of your past papers, it's here. Now, if you go on the website, it's not going to be there right away, but if you go CSEC math past papers, it will link you straight to it. And then from here, you have access to all, right? So I just wanted to quickly look at 2026 one, right? So just something to note here. As I say, we're just gonna go through this and then I'll go into the topics, right? Um, yeah. So you don't need to know your volumes, circumference, arc length. These things are given, right? Quadratic formula given. You don't need to learn it off, right? Sine, cos, and tan given. Area of a triangle given, right? Sine rule and cosine rule given, right? So I know some people were worried about if that would be there or not. It is there, okay? Make sure your calculator's in order, right? You'll see it have a lot of consumer arithmetic, algebra, and so on. We'll go through those, right? Sets, right? Go through that as well. Um, Look here, your construction, right? So construction did come, right? So you have to be careful with that. Go over your little construction. Go on YouTube. Look at the, because it's kind of hard for you to do it over Zoom, right? But you get the idea. Go over your construction. It was there, right? So make sure you have your construction set, all these things, right? Um, Map, area and volume, sine rule, cosine rule, transformations, right? Frequency polygon, and then graphs. We have our graphs here. Pattern identifying. This is one topic for sure that almost always comes, right? So, show you all how to handle those. Linear programming, this was shocking, right? Um, yeah, so on, functions, circuit geometry, this circuit geometry, vectors, matrices, and so on, right? Okay, so I want to start, we'll go backwards, right? So we're gonna start with matrices, right? So the way we deal with matrices, it is row by column, right? That's how your data is arranged. And know your rows go from left to right, and columns are up and down. So let's say I have a 2 by 3 matrix. We have two rows and three columns, right? And it looks something like 1, 4, 7, 2, 5, 9. Right? A, so the order of a matrix is number of rows by number of columns. So we'll have like a 2 by 3 matrix. That's the order, right? Now, addition, subtraction, pretty straightforward. You just do each element as normal. What I really want to discuss is the multiplication, right? This is where it gets a bit, you know. So multiplication of matrices. So steps, right? Steps. 1, find order of matrix A and B. 2, compare number of columns of A and number of rows of B. If they are the same, matrix multiplication can occur. If not, it cannot occur. 3, the resultant matrix is number of rows of A and, let's say has, and number of columns of B, right? And 4, multiply corresponding events and add. Right, so this is how we multiply matrices. So you first of all find the order of A and B. You compare the middle numbers. If they're the same, then you multiply. If the middle numbers aren't the same, then you don't multiply. Can't multiply. A resultant matrix has the number of rows of A by number of columns of B, and multiply corresponding elements and add. Now this looks like a lot of wording, and you're saying, well, what I mean, right? So what I'm going to show you here. Let's say I have some matrix A, which is 4, 1, 2, 5. Let's say I have B, which is 1, 3. And let's say I have some matrix C, which is 4, 5, 6, 8. Right? Say I have a matrix like that. Actually, let's do 1, 3, 3, 2, 5, 9. So let's say I want to find A times C. What's the order of A? So the order of A, this is so A is a 2 by 2 matrix as it have 2 rows and 2 columns. And let's say I have C. C is a 2 rows by 3 columns. I look at the middle numbers here. They are the same. Therefore, matrix multiplication can happen. You all agree with that? And this means that these two numbers here are what the AC would be. So AC would be how many rows it have? It have two rows and three columns. So that means it will have two rows and three columns. Ask your questions in the chat, by the way, if you all have any questions. So let me just repeat what I did there. I found the order of A, found the order of C. I check these two middle numbers here to see if they are the same. They are. So we got to go there. And my resultant matrix is these two outer numbers here. So I have of two rows by three columns. So now, how do we go about multiplying it? So watch here, right? This position here is my first row, first column,
First,
right? And this here, so if this is my first row, first column, I am taking the first row of A and multiplying it by the first column of C, right? So let me repeat that. This is my first row, first column. This is the position here. So therefore, I'll take my first row of A and multiply by the first column of C. So let's look at that. So as I was saying, first row of A, so that will be 4 by 1, because there's this one here, plus 1 by 2. So look at that. Multiply corresponding elements and add. So I take this by this plus this by this. This here is my, still in my first row, but this is my second column. So I am taking my first row of A, multiplying it by the second column of C, which is 4 by 3 plus 1 by 5. Likewise, this here is my first, first row, third column. So this, like this. So we go again. This would be 4 by 3 plus 1 by 9. So this here being my, underneath here now will be my second row, first column. I want you all to tell me what this would be. So put it in the chat. What what numbers would be multiplied here? Just giving you all like a 30 seconds just to make sure at least some of you all following along. Tell me what would this be here in the chat. So what by what plus what by what? What am I putting in here? Okay, so this is my second row by my first column. So it'll be 2 by 1 plus 5 by 2. And you can kind of pick up a pace of it. So this will be 2 by 3 plus 5 by 5. Now note something here. I always write second row, second column. Second row, third column. That always helps me to kind of make sure I have make sure I have an idea. All right, this is what, and even at my level, I would do that, right? 2 by 3 plus 5 by 9. Right, so this would be 4 plus 2 is 6, 12 plus 5 is 17, 12 plus 9 is 21, 2 plus 10 is 12, 6 plus 25 is 31, 6 plus 45 is 51. Right? And that's how you'll do matrix multiplication. Okay, but note something here, right? Just quickly. Now, don't worry if you're not getting it, remember, I'll upload it to the YouTube, right? So if I was to do, let's just say I have C times A. C is a 2 by 3 matrix, and A is a 2 by 2 matrix. Notice these two numbers not the same, therefore cannot multiply. Right? Right. The other difficult thing is inverse. Right? Only works for 2 by 2 matrices. So if I have a 2 by 2 matrix, A is A, B, C, D. The determinant of A is AD minus BC. The adjoint of A is DA minus B minus C. So A inverse is 1 over the determinant of A by the joint of A. So take a 2 minutes, everybody. If A is equal to 4, 1, 5, 1, find A inverse. So send it any chat once you're finished finding the inverse, because after this we're doing simultaneous. All right, so let's do determinant A is equal to 4 by 1 minus 1 by 5, which is 4 minus 5 minus 1. Your joint A is let's say 9:15 now. I'll try to push a little 50 minutes extra. All right. Um 1, 4 minus 1 minus 5. So therefore A inverse 1 over minus 1 by 1 minus 1 minus 5, 4, which is minus 1 multiplied by minus 1 minus 1 1 5 minus 4. Yes. All right. Good. You all got in there. Right. So simultaneous equations using matrices. So steps. 1. Make coefficients of x and y the matrix A. 2. Make x, y matrix B. Sorry, make matrix X. Make um, remainder matrix B. 4. Write AX equal to B. 5. Find A inverse. 6. X is equal to A inverse by B. So let's just say I have 2x plus y is 5 and x plus y is 3. Let's say I have something like that. I say, okay, I make the coefficients. A would be 2, 1, 1, 1. X would be xy equal B is 5, 3. So now I need to find A inverse. So A inverse, let me just find the determinant A. It's 2 by 1 minus 1 by 1 is 1. The joint A is 1, 2, minus 1, minus 1. So A inverse is just 1 over 1 by 1 minus 1 minus 1, 2, which is 1. Well, 1 by that is just 1 minus 1, 2. So we know xy is A inverse by B, which is 1 minus 1, 1, 2 by 5, 3. And we know we're supposed to get from here, this is a 2 by 2, 2 by 1. We're supposed to get a 2 by 1 matrix. So it'll be first row by first column, 1 by 5 plus minus 1 by 3, minus 1 by 5 plus 2 by 3. So 5 minus 3 is 2. Minus 5 plus 6 is 1. So I want to say fairly straightforward because it could look a bit confusing, but the premise itself is um not too bad. So let me go through this again. So what I did here, I take the coefficient of x and y and make that a matrix here. I then take x and y and make my other matrix here. And then finally, that is equal to this side here, 5, 3. So that's how you set up solving a simultaneous equation with the use of matrices. So let me repeat that. Take the coefficients for x and y. So the numbers before x and y. So 2 matches with 2, 1 matches with 1, 1 matches with 1, 1 matches with 1. Then I have x, y, x, y, and then I have 5, 3, 5, 3. So the premise is now I need to find the inverse. So to find the inverse, I find the determinant of this, find the adjoint of this. I get my A inverse here. Xy is equal to A inverse by B. This is just something you just have to know. All right. So A inverse by B. And I take my A inverse multiplied by B. The usual matrix multiplication. 1 by 5 plus minus 1 by 3. And then minus 1 by 5 plus 2 by 3. And I get my values of x and y. Okay. So I know it's a bit confusing. Try it. Try this now, right? Again, we three days from the exam. If you don't understand it, study it. Study it, right? If you're not catching it, now is not the time to try and learn new things, right? So let's just see where you could figure out from it, right? So let's say I have 3x plus y equal to 2 and 2x minus y, this is 2x plus y is equal to, oh, make it too easy by the same time. Right? There's 1. Use the matrix method and solve for x and y. Put your answer in the chat, what answer you get, right? All right, so try it. Let's see. I want you all to note something here, right? In the question itself, they'll ask you, they'll tell you to solve using the matrix method and so on, right? You have to use what they tell you to. You can't use concepts that they're not tested on. So if you solve the simultaneous equation regularly, they will not give you marks. The only time you could do that is if they didn't specify a method. Okay? If they didn't specify a method, then you're good to go. Right. So let me do this. Yeah. So we have 3, 1, 2, 1 by xy equal to 2, 1. All right, determinant A, 3 by 1 minus 1 by 2, which is 1. The joint of A is, since the determinant is 1, good to go. 1, 3. So A inverse is 1, 3 minus 1 minus 2. So xy is 1 minus 1 minus 2, 3 by 2, 1, which is 1 by 2 plus minus 1 by 1 minus 2 by 2 plus 3 by 1. 2 minus 1 is 1. Minus 4 plus 3 is minus 1. Right? Cool. As I was saying, guys, if you're not getting it, now is not the time to try and teach yourself something new. Focus on the marks you could get. Right? Your marks is out of 100. If you're not getting this, small thing. Look at the things you can get. All right? That being said, though, a matrix is singular if its determinant is 0, i.e., determinant of A equal to 0. I is the identity matrix, which is 1, 0, 0, 1, and A by A inverse is equal to A inverse by A, which is I. All right? So these are like some niche questions you could bring and ask you. All right? And ask you these. Some niche questions. Okay. Here's a major one that everyone seems to worry about, right? Bearings. So bearings is a representation of length and direction of places from each other, right? It is taken from the north line and moves clockwise, right? From means angle is at that point. To means angle is at other point, right? Uh, the angles between any two north lines must add up to 180 degrees, right? Okay. We use a combination of sine rule and cosine rule. So let's say I have, I'll give you one that's not too bad. Right, so as I say, let's just go over this again. Bearings is the representation of a length and direction of places from each other. It is taken from the north line and moves clockwise. From means angle is at that point. To means the angle is at the other point. The angle between any two north lines must add up to 180 degrees, and we use a combination of sine rule and cosine rule. So the sine rule is A over sine A equal to B over sine B equal to C over sine C. And it is used when an angle and the side directly opposite the angle is given. And the cosine rule is A squared is equal to B squared plus C squared minus 2BC cos A, right? And this is used when sine rule fails. I know you can't use it. And these are given in the formula sheet we went through it, right? So yeah. Um see if they brought one here. Look, you see, look. Then the matrices, give it this, turn B inverse, and look the same thing I'm telling you about, right? The simultaneous. So notice for Jan, they didn't bring it, right? For Jan, they did not bring a bearing. So a feeling, a feeling for your exam, they'll bring it. The fact that they didn't bring it is very, very strange. Yeah, why not? I don't get one that we'll work out together, and then one. Right. So 2014 is actually when good old Mr. Niner was in Form 5 like y'all. And this is the exam he wrote. Yeah, so tomorrow we'll do transformations. That's fine. Yeah, I'm not today yet though. So, all right. So look here, right? I'm gonna do this one, and then, all right, Drill. Thanks, sir. I'm gonna do this one with you all, and then we will I'll give you all one to try. So let's read all the information they gave us, right? Q is 80 km from P. All right, so you have that. R is 100 km from Q on a bearing of 66 degrees, right? So that means this here is 66 degrees. PQR is, notice it said, of P from Q, right? So if it's from Q, that means that is where, from our notes here, from means that is where the angle is at. So we know that angle is at here. So this is 66 degrees. Cool. So they want the distance PR from two decimal places. Okay, so let's look and see what we have here. So, looking okay, PR from two decimal places. Do I have a side and the angle directly opposite it? I have this side, I don't have this angle. I have this side, I don't have this angle. Cool. So that means that failed one time. So that means I have to use cosine rule. So immediately said, okay, let's set it up. Oh, I should also draw this for you all, right? A, A, B, B, C, C. So I'm going to set it up now. See how I don't have a side and the angle directly opposite? Cool. That means immediately I'm using cosine rule. So I said, okay, PR squared is QR squared plus QP squared minus 2 by QR by QP cos 54. How do I know that's 54? Because I'm taking the side opposite it here. So say, okay, this is 100 squared plus 80 squared x 2 by 100 by 80 cos 54, which is see, 100 squared plus 80 squared minus 2 by 100 by 80 by cos 54, which is, so PR squared is 29668.96. So PR is equal to the square root of that, which is 172.25. They set to two decimal places, right? Also, all those who doing AdMats and physics, make sure your calculator is in degrees, right? I had a student, I do the whole exam in radians when I was supposed to be in degrees and get all the wrong answers. Pissed me off. That was this student always give me trouble. Aaron House. He really give me trouble. And he made the mistake and put all his answers was in radians instead of degrees, and yeah. He was always a troublesome. But always make sure your calculator matches this. And then math will always be in degrees, not radians, right? So we got that there. And now they want QPR, right? Or the team, QPR. Just know that this middle letter here tells you where the angle is at, right? So they want this angle here, theta. So again, I do the search. Do I have a side on the angle right opposite it? Yes, I do. I have this pair in here, so I could use sine rule. So 172.25 over sine 54 is equal to 100 over sine theta. I cross multiply. 172.25 sine theta is 100 sine 54. So sine theta is 100 sine 54 over 172.25. You can work it out, eh? I just sine inverse 100 sine 54, which is equal to 54.25. What? Yes, yes, that is correct, right? But there is no circle here. So in the question itself, you are correct to say if they had say that, then you could have done that. But there's no circle here, so we can't make that assumption, right? Right? And look, I made the same mistake as this Aranous fella, right? Because this actually here is 83.64. I was waiting for somebody to tell me that I worked in radians, you know. Nobody ever do that. So this is actually 6995.44. So we're at 6995.44, right? And I could tell that was wrong because I know it's way beyond these values here, all right? So 83.64, right? So 83.64, 83.64, which is 100 sine 54 by 83.64. And then I find sine inverse of so, which will be 75 point, well, it'll be 75 degrees. Okay, so notice one is a lot, but with bearings, just take your time. And you have to remember you'll get marks. So even if, let me just say you don't get the right answer, you're getting your marks for your working. So make sure so you put all your work in. Let me just get a question for you all here now. All right. I want you all try this one for me. All right. I'm giving you all 5 minutes to do this one. So tonight we did bearings and um, matrices. So that's two big ones. Tomorrow I want to do transformation and vectors. Right? Vectors is normal, transformations, and I'll also try to do circle theorems tomorrow. Because circle theorems, majority of y'all will just be guessing, right? And chances are you'll be right if you're guessing, but there is a method to the madness, and I want to show y'all how to do it. And like, not all the answers could be angles in alternate segments. Majority could be, but not all of them are. So we want to go through those three things, right? As y'all doing this question here, y'all try it, and so on. Send me answers in the yeah. So I'll do an angle of elevation and depression as well, right? Um, let's see there. Right. Um, yeah, after this one's up, we will do an angle of elevation and depression. Um, right. What we're saying is that when you're doing your questions and thing, I Mr. Seaton put the link for you all. In there's also my WhatsApp number. When you're doing your past papers and thing and you don't understand something, send me it. Send me it. I'll take a look, right? I'll take a look at it. Um, Now is the time you do all your practice papers, all you have so much things available. ChatGPT, Claude, Gemini. I won't use ChatGPT. I'll honestly use Claude or Gemini to try and study, right? So yeah. Right. So I'll give you all 5 minutes. Try this one. Well, look who finally decided to show up now. Usual thing with Jeremy, you know. Never in my class. All right. Let's um let's run it for Jeremy, right? Hoping it's not inconveniencing, yeah, Jeremy. Let's go. So the first thing they say, they want this angle X here. So we know that this is a straight line. And a straight line has 180 degrees. So pretty straightforward. X plus 56 plus 48 is 180. X plus 104 is 180. So X is 180 minus 104. X is 76 degrees. Cool. We lock in 2 marks there. And we in touch angular. We in touch no bearings, right? The distance from Port City to Queenstown is 220. And the distance from Queenstown to Riverdale is 360. They want the distance RP. So we know it's either sine rule or cosine rule. So we say, okay, part 2. Do we have an angle on the side directly opposite? No, we don't. So we're going to have to use cosine rule. RP squared is 220 squared plus 360 squared minus 220 by 360 cos 56. And you can plug this straight in calculator, right? RP squared is 89423.84. So RP is the square root of that, which is 299, right? So 299. Now they want the bearing of R from P. So we need the bearing of R from P. So we need the angle here. So it'll be this whole thing here. So I already have the 1 to the 2 part. We need to find this little piece here to add to it. So how could we do that? Do we have an angle on the side opposite? Yes, we do. All right. So 299 over sine 56 is equal to 360 over sine theta. So 299 sine theta is 360 sine 56. So sine theta is 360 sine 56 over 299. So theta sine inverse 360 sine 56 over 299, which is, let's just leave it here. 86.54. But do not forget to add this. So you put bearing is equal to the 132 plus 86.54, which is 2, 1, 218.54 degrees. All right. All right. So I know we wanted to do a bearings, but angular elevation and depression, but we'll do that tomorrow, right? So tomorrow I'm gonna try and put class for a little longer, right? So we'll try to go to like probably like 9:45 or so, right? So the topics tomorrow will be we'll do one um elevation slash depression, as in the angle, not how we feel about this exam. Two, we will do transformations, right? Three, we'll do circle theorems. Thanks, Abby. Circle theorems. And four vectors. We'll try to hit all these four, right? So, all right, guys. So I will upload it. I will post it on the 4.5. Sorry, yeah, well, it's still named 4.5. The 5.5 Google Classroom. I'll post the YouTube link. Hopefully, them men will share it here. I hope so. If not, just reach out on WhatsApp. I'll send it. Yeah, I hope everyone have a wonderful one Mother's Day tomorrow if you're celebrating. If you're not celebrating, enjoy the mother figures in your life. And yeah, tomorrow we're gonna push, try to do a 145 minutes, maybe even 2 hours. All right. So y'all take care, guys. Thanks for coming. Tomorrow.
Have a good night, sir.
All right, Jeremy. All right, thanks.